Okay, here's the UALR final exam review for college algebra, problem number 24. This is a big problem. Takes up a whole page. Consider the following function: f of x equals x to the fourth minus x cubed minus 30x squared. Find all real zeros of the polynomial function. To do that, we're going to graph it. And when we look down here, they give us graphs, and look, they give us windows that we can base this off of. This looks like each tick mark is 100. So it looks like here we go x's from negative 10 to 10, y's from negative 800 to positive 800. So I'm going to go to my calculator, and I'm going to set the windows up based on the windows that I'm looking at on the graph. So I'm going to hit window. Well, let's put it up here. Window, and I want to go x's negative 10 to 10, x min negative 10, x max 10. And I'm going to go down here to y min. I'm going to go negative 800. Well, the tick marks go 3 lower, and each tick mark is 100. So it's going from negative 800 to positive 800 here. With me there? And then I'm going to get the max is going to be 800. Whoops, there it is, 1,000. All right, now I'm going to go put my function in my y equals. So that's x to the fourth minus x cubed minus 30x squared. Then I'm going to tell it to graph. Now this one's nice and pretty. Looks like it intersects at the actual whole number x values. If that's the case, how many times are we going to have zeros? How many zeros are we going to have here? How many real zeros are we going to have? 3? All right, I'm going to look at the table and see if I can spot all 3 of those first. At negative 5, y is 0, so negative 5 is a 0. At 0, y is 0, so 0 is a 0. And at 6, y is 0. So it looks like negative 5, 0, and 6. Or the zeros of my polynomial. And then it asks me to determine whether the multiplicity of each zero is even or odd. For the smallest x value, then the next smallest x value, then the largest x value. So we're going to look back at the graph. The smallest x value, which is 0 for the function, is negative 5. The graph goes through at negative 5, which makes the multiplicity odd. At 0, the graph bounces off the x-axis, which makes the multiplicity even. And at 6, it goes through the graph, making it odd also. So that means the multiplicity for negative 5 is odd, for 0 is even, and for 6 is odd because of the way it intersects the x-axis. It says determine the maximum number of turning points on the graph of each function. The turning points are the places where the graph goes from decreasing to increasing or increasing to decreasing. So they're the maximums and the minimums, maxima and minima, right? Now this has 3, but this says determine the maximum possible number of turning points. That's based on the degree of the function. It's always the maximum possible number of turning points is 1 less than the degree of the function. Here, the degree is 4, so there's maximum of 3 turning points. Maximum of 3 turning points. Then use the graphing utility to graph the function. We already did that so we could find the zeros. So we got to match that with our graph. Let's see. That looks like this first one, doesn't it? Doesn't look like the second one, does it? And scroll up. Doesn't look like this one over here, the last one. And doesn't look like, so definitely the first one. That's problem number, let's see, make sure there's no more. That's problem number 24 on your final exam review. Pretty painless, right?